Hey guys, hope you're all doing well. Second podcast for today, technically the third, is section 2, graph exponential decays. So this is actually going to be a quick section because I just taught you 7.1, and 7.2 is almost exactly like section 1, except for the graph looks a little different. So let's get into exponential decay. Alright, let's draw a picture here. What does an exponential decay look like? I already showed you that. So it starts, something like this. Starts with a lot of things and it goes down, decays. Goes down, 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 keeps on going until it gets closer and closer to the x-axis. Alright, so this is y equals ab to the x. Actually, both of these are y equals ab to the x. What tells you it's a decay? If a is greater than 0 and b is actually between 1 and 0. So if b is 1/2, 2/3, you guys get the picture, right? So an example of this, I could just make one up here. We can say this is y equals 2 times 1/3 to the power of x. It would look like this. It's an exponential decay. How? I just look at a. Is it greater than 0? Check. Is this between 0 and 1? Check. This is an exponential decay. Alright, now so they have you, first question, they have you graph a normal exponential decay. Y equals 1/2 to the power of x. Now what is the a in this case? This is the b. Anything to the power of x, this has to be the b. So where's the a? A is equal to 1 in this case. Okay. Now I can tell it's an exponential decay because a is 1 and b is between 0 and 1. So therefore, in my mind, I'm just kind of doing this in my mind. It's might not exactly be this, but it's just like this somehow. It could be a little steeper, but it has this form right here. Okay, so all you have to do is put this in your calculator, get some coordinates, and boom, you get a few coordinates. Oh, here's a coordinate, here's a coordinate, here's a coordinate. There you go. Draw yourself a nice curve getting closer and closer to the asymptote. Alright, so that's basically example 1. So go to your calculator, get your table, and then use those coordinates to make your graph. And so they plot all these coordinates, make a nice curve. Notice the curve, what it looks like. Starts high, goes down. Here's your asymptote. Alright, that's all they ask you for. Just say graph. You're done. Next one. Graph y equals 2 times 1/4 to the x. Is this a decay or a growth? I look at A, yes, checks. Look at B, is between 0 and 1, check. It is a exponential decay. So therefore in my mind, right there, I'm just doing this in my mind, alright? So now it might look a little steeper in this case. Get your calculator, type it in, get some coordinates, draw the picture. That's all they want. Just learn how to graph. Alright? Now you know a couple points just by looking at this equation right here. Remember, 0, a is always a part of an exponential function. 0, a, 0, 2. So you put 0, 2. And then 1, put 1 in here, and that's easy to do. 2 times 1/4 is 1/2. There you go. 1, 1/2, and then you know it's going this way because you know it's a decay. So that's all they did. Actually quick and easy. Alright. Okay. Now what about this right here? Letter B. Graph this function. Y equals -3 2/5 to the x. Well, it's not this anymore. If it was this, a would be positive. Since a is negative, it just does one thing. The b is between 0 and 1, so I know it has this thing instead of going up, right? And going up, that would have been a growth. This should your decay be based off of this right here. Since that's negative, it's just flipped across the x-axis, so that's an important point. If a is negative, it is a reflection across x-axis, just like the growth right here. If the growth was negative a, it would be right going down like this. Exact opposite. So since this is negative, let's draw a little picture. In my mind, I'm just saying, okay, it flipped, so therefore it was this way. If that flipped down, if this flipped, it would look like this, right? If you put this up here, you might be able to see it better. It flipped over the x-axis. There you go. So did it move left, right, up, or down? How can you tell? Remember the h and k, right? It's x minus h plus k. There is no h, there is no k, so therefore it didn't move left or right. It didn't move up or down. It just flipped across the x-axis based on that negative a. That's it. So you're going to find your picture, if you put this in the calculator, you're going to find it looking something like this. Alright, so you can go to your calculator, get a few points, and you know 0, negative 3 because 0, a. So 0, negative 3 would be here, and then put 1 here, so negative 3 times 2/5 is negative 6/5, so 1, negative 6/5, you know, something down here. Right, so just draw your curve. Okay, that was my elbow on the table here. Okay, now, what else? What else do you need to know? Yeah, you can practice these functions here. You should be able to know a function by now just by kind of looking at the equation. 2/3 x, that's a decay. So as you can see, it going down, decay. This has a negative a, and it has no h and k, so therefore it didn't move left, right, up, or down. So it's just a negative. So it was up here, decay, now it's flipped down here. It's going to look something like this. Alright, and you get a few good coordinates and be able to graph it. This right here is a decay based on this, and more importantly, this really is between 0 and 1, so normal decay. Alright, just get the coordinates, get the right coordinates. You guys get the picture. Alright, example 3. 1 is graph. That's important. But 2, even more important for me, state the domain and range. You did this for section 7.1. All you have to do is look at your h and k. Alright, so x minus h plus k. Now forget about these right here. If I had to draw a picture of just 3 times 1/2 to the x power, what would that look like? That would be 3 1/2. This is a decay. So originally it would look like this, right? But since it has this h and k here, that means it moved up, down, left, and right. So how did it move? H in this case is equal to -1. K in this case is equal to -2. This tells you, H tells you left or right, so it moved left 1. -2 in the K means it moved down 2. So therefore I'm going to take this picture, I'm going to go left 1, down 2. So the asymptote right now is, I know it's a little sloppy, the asymptote is right here. It's going to move down 2. 1, 2. So it's going to look like this. And I'm just going to, say, okay, I'm going to move this left 1. So it's going to be a little bit more on this side. And it's going to have an asymptote that gets closer and closer to this guy right here because it moved down 2. So look at this picture right here. What is your domain? I told you in the last video, your domain, think about what could x be. X could be positive? Yes. X could be negative? Yes. You can have a 1/2 to a negative power, right? Could it be 0? Yes. So actually all real numbers. For exponential functions, whether it be decay, whether it be the other one, can't think of it, growth, It's always all real number domain. That's easy points right there. The only thing that really changes for these functions is your range. And all you have to do is look at the picture. Look at it. Forget about the first one. That was just my sketch of the original. So here's the end product after we move H and K, right? Look at this. Domain we already got. Range. What are all the Y values in this case? Well, since this is an asymptote right here, it's like an imaginary line that the graph will never touch. It's everything above this line, right? So range always starts out Y. Y is, it's either going to be greater or less. What do you think? Well, it's above this thing, so it's going to be greater. Should it be equal to? No, because it'll never touch this line, so no equal to. Y is greater than what number? Well, what's the lowest Y value here? Well, right there. It gets closer and closer to this, which is -2. This number is basically, I think I can say this, it's basically always your K value. Always is here. Whether if it's greater or less depends on the problem. Okay, what if that was flipped? Okay, it would be the other way. It would be less than if this thing flipped down, right? It could be going down. I'll give you a small example. This is, you don't need to write this down for this problem. You might get confused, but if you had, let's see, yeah, if you had this right here, this range would be Y is, since it's going down, it's all down right here, it's less than, whereas the asymptote in this case, it looks like it's going to be 0, right? So it's Y is less than 0 for your range in this problem. So you get the picture, right? It always deals with your K value. Where did it move? The X value, the H value doesn't really tell you much besides it moves left or right. It never affects the domain. Domain's always all real numbers. That's it. That's the main idea for examples 1, 2, and 3. Alright, back to the video here. Last example is an exponential decay model. This is basically the same screen as I had on section 1, only it was exponential growth model. And the only thing different between that one and this one right here is this. The exponential growth was 1 plus r. Exponential decay, it subtracts things, right? You start with a high amount of things and it decays, it goes down. So this is the same thing. This is different by subtracting the amount. So the only thing different, plus for growth and minus for decay. So try to remember that. And once again, these are bullet points, not negative signs. Okay, bullet point, bullet point. Should have changed that, but that's alright. Here we go. So just like before, A is the initial amount of whatever you're talking about, whether it be, viruses or whatever, money. Okay. R is the percent decrease expressed. Remember, don't forget that this R has to be in decimal form, meaning 6% is really equal to 0.06 and so on and so on. Okay, that's key. People miss that all the time. And 1 minus R we call is the decay factor. So this thing right here is called decay factor. Alright, and that's it. So let's apply this model right here to a problem. When would you have something? When would something decay exponentially? Think of some real life examples. One thing is money. Well, why isn't this working? Like this. Example 4, snowmobile. New snowmobile costs $4,200. The value of the snowmobile decreases. So right there is your key. The value decreases by 10% per year. This tells you right away it's an exponential decay. Now I could say in a word problem, I'm not going to tell you right away, I'm not going to say, hey, this is an exponential decay. Use your model. Okay, I'm not going to say that. I'm going to just give you a scenario. What if I said, like the other problem we had, section 1, we put this money in the bank and this increases by 8% a year. As soon as it says increases, that's the exponential growth, increases. As soon as it decreases, that means decay. Alright? So, as soon as I see this, I go to my formula, y equals a times 1 minus r to the t power. So a is the initial amount. How much was it initially? A new snowmobile, 4,200. That's what it was initially. 1 minus my percentage rate, which is 10, but don't put 10 here. Put the decimal form of 10%, which is 0.10 or just 0.1, to the t power. So, I didn't scroll far enough to give you a question yet. My fault. But the first question will be, one, it says to graph the model. That's fine, no problem. But the main idea is, it says use the graph to estimate the value after 3 years. So, number one, sorry, I'm mixing you up, kind of looking ahead and whatnot. Write an exponential decay model right there. Y equals a, 1 minus r to the t. Fill this stuff in. Y is equal to a is 4,200 initial. 1 minus 10% is 0.10 or 0.1 to the t power. Actually, we're going to leave t here because it just wants the model. Then it says estimate after 3 years. So this is part 1. So if I ask you this on the test, please put this as part 1. This is the model after 2 years. Okay? This is part 2, estimate the value. So part 1, part 2, estimate, which is y is equal to 4,200 times 1 minus 0.10 to the t is 3 years. Remember, what if I said 18 months? 18 months is 1.5 years. Okay, be careful when I kind of say, don't just throw the number in here. Alright, so all you have to do now is put this in your calculator. 4,200, you know, put this, put to the third power, just exactly the way you see it, and you got your answer. So, the answer is $2,500. Nope. Is that it? No, $3,061.80. So $3,061.80. Make sure you have a dollar sign. There you go. That's when you put that in. Alright. So if you didn't get that number, you typed it in the calculator wrong. Alright, what does that mean right there? That's how much this thing is worth after 3 years. If you know cars and stuff, as soon as you buy a car, you take it off the lot, it's called what we say, it depreciates. Okay? It goes down in value very quickly. So never invest too much money in a car. It depreciates too quickly. Alright, so there you go. This is how you use the exponential decay model. Now it could ask you something else, like this says graph the model. Okay, put that model into the calculator. Look at the graph. You'll see an exponential decay. But then it says to use the graph to estimate when the value of snowmobile will be $2,500. So you're going to see the graph here. And what are you looking for? 2,500 is your which value in there? It's your y value, right? Y equals 4,200, 1 minus 0.1 to the, you can say to the third or to the t. Here's like your x value, and here's your y value. So it's giving you basically y is 2,500. You have to go find x. So it says use this. So you can go up to 2,500 and then kind of look at where it is, wherever this is at. You choose that value. Okay, how many years? Or you can just solve this equation for t, which you know how to do based on last chapter. So I'll just show you the slide. Make sure you understand what's going on here. Alright, so that's part 1. We found out how much money it's worth after 3 years. And then the next part, Okay, here's what the graph really looks like. I was just drawing you a normal decay. Here's what it looks like if you put in your calculator, you use the window key. Okay, they said look at 2500, which is here. You scroll over. Okay, what's this point right here? And you come down. That's about 5 years. So this thing will be worth $2,500 after 5 years. Okay, that's how you can use a graph to figure it out. And that is basically section 2. All you guys got to do is practice a little bit. You should be fine if you understand section 1. Kind of easy, actually. See you guys soon.